Hello, and welcome to the Trepid Technologies Security Plus course. My name is Johnny Bandon, and I will be your instructor for this video series. This video will cover Domain 1.6 vulnerabilities. Now let's get started. Cloud-based vulnerabilities happen off-premise, away from your enterprise, and are the responsibility of the cloud service provider for some cloud deployments. If the cloud service provider provides, let's say, for instance, software as a service or a platform as a service, then that CSP or that cloud service provider is responsible for securing infrastructure and the software of the services they are providing. However, if the cloud service provider is providing infrastructure as a service, written as this, I'm going to put CSP up here for cloud service provider if you didn't know what that stood for. If they're providing you with infrastructure as a service, then your administrators or yourself, being the security administrator, are responsible for securing the operating systems in the infrastructure your organization is leasing from the CSP or cloud service provider. So really, depending on the types of cloud deployments that your organization is using, is going to dictate how you secure your off-premise infrastructure in the cloud. And we'll go over these different cloud deployment models later in the series, more of a deep dive. On-premise vulnerabilities happen to your local network. So this is something we should all be used to as administrators. We have to secure the equipment and software that we're responsible for, right? We consider our local area network on-prem or on-premise. A zero-day attack is a vulnerability that has not been patched or disclosed to the public. So, for example, an APT will typically perform a zero-day attack and is a significant threat to your network and enterprise because there's no fix for a zero-day attack, right? We use the term APT, which we learned in our last section, because that's usually how zero days are created, by a team or an individual that's smart enough to exploit a vulnerability in a system that no one else has before. So how do we prevent a zero-day attack? Well, you can't really stop the zero-day attack from happening. If someone finds an exploit in the system that even the vendor didn't know about, that's an exploit. It's a zero-day. But we can help prevent the spread throughout your network by implementing network segmentation. You can do this logically or physically, and you can separate your network through VLANs, micro-segmentation, or even an air gap. So we can use VLANs or micro-segmentation, which is east to west segmentation, which we'll discuss later on in the series, to logically separate your networks. So if a zero-day happens in the accounting department on the accounting VLAN, right, then maybe we can stop it from spreading to our R&D department, research and development, by putting this in VLAN 10 and this in VLAN 20. Or we can perform a physical air gap where we actually create two separate networks, maybe our enterprise network, right? We perform that air gap, and then we have our manufacturing or our SCADA systems. And if a zero-day attack happens in our enterprise, it's not going to be able to reach our SCADA systems or our manufacturing equipment because we put a physical air gap, something that physically separates those networks. And again, we'll go into what a SCADA environment is later on in this course. Next, let's go over weak configurations. So weak configuration is when an organization leaves the defaults on equipment or software. For example, let's say you buy an Internet of Things device. So you buy an IoT device, stands for Internet of Things, and you buy it for the office that lets employees turn the conference room system on and off with their voices. So let's say you buy like an Alexa or some version of it, right? Well, if this device connects to your enterprise Wi-Fi or network, you must ensure that the default username and password on the device is changed. As an administrator, you must ensure that a threat actor cannot just look up a product's default username and password on Google and then use it to log into that device, right? That could be bad. And some hardware you may purchase either for your home or office may also not be able to use any advanced security protections. Like it may not support encryption data, or it may not support multi factor authentication. And then we have some third party risks that we need to talk about. So, when your organization is working with a third party to achieve organizational goals, documentation must always formally or informally define the organization's relationship. So, you're going to have formal and informal documentation. That's going to help guide the relationship between a vendor and organization or between two organizations. So, an MSA or a master service agreement is a contract that outlines all the work a vendor will perform with an organization. An SLA or service level agreement will specify the technical level of service a third party will provide. An example of this: a cloud service provider may boast that their SaaS applications or software as a service, let me write that down again, applications have an uptime of 99.99%. But in that fine print in their SLA, they may define different terms of their availability, right? So what you can go to market with and advertise sometimes will not always match up with the SLA, right? Because let's say you have a 99.9% uptime on one application, but 98% on a different application. You're still allowed to go to market with that 99.9% value, right? But you got to look at the fine print on what they're actually providing. Sorry, let me go back. And then we have an MOU. An MOU is a memorandum of understanding and is an informal document that will outline what type of relationship organizations will have. An MOU is more or less a guideline on what two organizations should expect from each other. So there is no misinterpretation of the type of relationship. A BPA is a document generated when two organizations decide to go into business with each other. So these are just some of the third-party risk documents that you may find that you need to use in your enterprise. And this is to protect yourself and the organizations you work with. All right, so now let's go over some other threat actors that we need to talk about, or vulnerabilities. So vendor management. So in technology, vendors are an essential part of daily operations in business. When a vendor puts out a patch to your production systems without your consent, that can be a big problem. So choosing the right vendor for your organization could also impact security. Because just in that example I just said, right, where they put out a patch without your consent, and that brings systems down, that violates the A in the CIA triad that you are supposed to care about. If we haven't gone over this yet, let's go over it now quickly. Confidentiality, integrity, and availability. These are the concepts, or the CIA triad is a concept that you care about as a cybersecurity. It kind of guides us on what our purpose is, right? So vendor management is a part of your role, right? So we must be able to trust the vendors we use and research which vendors can be trusted to deliver unaltered products and vendors that won't make changes on us. A lot of mistakes companies make when choosing a vendor is not properly vetting the vendor's actual supply chain. So if your business has dealt with the US government to deliver hardware or software, there may be regulations that outline which vendors are trusted to be used by the US government. As of this recording, it's July 15th, 2022. And it's a perfect time to discuss vendor management because just a couple of days ago, a CEO of a remanufacturing tech company has been made $1 billion selling fake Cisco equipment. Yes, you heard me. Fake or altered Cisco equipment. Imagine you're the security administrator that decided to go with that vendor, and now you have a fake Cisco equipment that could have been altered in many different ways. So vendor management is important. Even in the year 2022, we still have to worry about it. In your enterprise, critical systems will be needed to keep the daily operations up and running for your business. Some systems are so critical that if there is downtime, the organization loses money every minute that system is down. When a piece of hardware or software becomes that single point of failure, you must ensure that there is a system or processes in place for the failure of that critical system. Now, let's think about what would happen if a critical server that runs our organization's manufacturing becomes end of life and the vendor no longer supports that system. This could leave unpatched vulnerabilities or even complete degradation of that system. So, as security professionals, we must keep this in mind when we integrate systems into our enterprise. So, all that to say, system integration is not just as easy as going to Best Buy and buying a computer or going with some vendor that's up and coming. If you're going to have long lasting equipment in your enterprise, you need to make sure you vet that vendor and you integrate systems cautiously, right? You're going to want to have good change management for that hardware acquisition, especially if you're planning on buying an OS or hardware that is close to end of life to save some money, right? You got to think about this system integration and how it's going to affect your enterprise. Let me just put this up here. EOS, this is end of life. This is end of service. Things you have to consider when integrating new systems. Now let's move on to outsourced code. So in application development, it's something that you need for your enterprise, right? You need developers, you need someone creating applications for the unique products that you're going to give to your consumers, if that's the type of business you run, right? However, as security professionals, we must ensure that our development teams are not using third-party code that is vulnerable or has known bugs that cannot or have not been remedied. So let's say a library that a developer wants to use in the code has a known CVE. CVE stands for Common Vulnerabilities and Exposures. So let me write that out for you. So this CVE is going, for every vulnerability, they have a CVE. And you can look up the CVEs on the internet to see what type of vulnerability or exposure is part of that software or hardware, right? And if your developers are integrating third-party libraries or third-party code into their applications that are going to be on the business side of things, you're going to want to make sure they're not integrating code that maybe have a CVE or hasn't been tested, right? So you got to be careful when you're outsourcing code from a security perspective. Now let's go over weak patch management. So vulnerabilities will occur in our enterprises. That is something you as a security practitioner can sometimes not prevent. It's going to happen. There's going to be an exploit in a system at some point that even the vendor wasn't aware of. So what can we do to be proactive? What we can do is use corrective action on our systems by implementing a patch management system that regularly patches known CVEs in our environment. A weak patch management system could leave our enterprise exposed and vulnerable to threat actors. So this is one of the first lines of defense to actually protecting your network. Having some sort of patch management system, whether that's built into Microsoft Windows Update, whether that's you deploying a third party, you need to have something in place that's going to scan and patch our systems. Now let's move on to firmware. So firmware is a software that is burned into hardware to give it functionality. So think about your computer's BIOS that functions without the operating system. That is using firmware. And firmware, once altered, can be hard to revert. There are preventative measures we can use to protect the firmware of our devices. One example is using TPM, a trusted platform module, to authenticate that firmware has not been changed. The way TPM works is essentially it's going to go back to a store of hashes on the hardware and make sure that when that hardware boots up, it has the same hash as the stored hash in that TPM. TPM stands for Trusted Platform Module, which we will talk about later on in the series as well when we talk about securing our endpoints. trusted platform module. And then, of course, we got to make sure our operating systems are not vulnerable as well. So we got to make sure they're getting patched. We got to make sure that we're not using end of life or end of service operating systems that will no longer get patches. So you want to make sure that this threat vector is minimized, right? We got to harden our operating systems. And now let's go over some data breaches. So a data breach is something organizations fear in today's world. Because once a data breach has occurred, there is no hiding it once it gets out. Whether your organization reaches the front page news of CNBC or starts to trend on Twitter, a data breach can strain an organization's reputation, putting you at financial risk from lawsuits or even compliance fees, right? So it's something you don't want for your organization. A data breach can lead to financial risk, loss of your reputation, and also identity theft. Identity theft can also occur due to credentials being breached and then posted on places like the dark web. Something you don't want for your organization. So CompTIA just wants you to know the definitions of data breach and what it causes, right? Something we have to know. Kind of common sense if you think about it, but something you as security administrator, you'll have to quantify and explain to stakeholders, management, right? And the last thing we're going to talk about is legacy platforms, which we kind of already went over in the other slides. But these are systems that are EOL or EOS, end of life or end of service. If you have a critical server that you can't have replaced for whatever reason, right? It's the manufacturing or whatever the case may be. Now you're taking on a known risk because once a device or software has become EOL, EOS, it will no longer be patched and it'll be unsupported by the vendor. So we have to try to use some strategies and controls to try to prevent these vulnerabilities from being exploited on our network. So one thing you can do is start implementing some firewalls or network segmentation, right? You're going to have to use a defense in-depth approach by adding layers of security to your network so that if there's vulnerabilities on your EOL systems that you can't patch, at least we have some lines of defense in place. All right, that's going to wrap it up for this Domain 1.6 vulnerabilities. I want to thank you for viewing and stay tuned for our next video where we'll go over Domain 1.7 security assessments.